the first thing we want to do is to have a kind of visual representation of what we're going to do here. So in this case, essentially what we want to do is we want to use the command picture frame, which you might be familiar from Rhino 1 if you did that modeling the precedent. So we're going to hit enter. So I just typed in picture frame, enter, and essentially what this is going to allow us to do is to place this image as a reference image in our Rhino window. So in this case, we'll click on Fedora dog. I'm just typed in 0 for my corner, and then in this case I'm just going to drag it out to the size we want. So you can see there it is in our Rhino window. So it's a surface now, so this is good, and we're actually not referencing this geometry. You don't need to place the image in Rhino, but I find it's just a lot easier for sizing. So let's open Grasshopper. So this being a surface, we're going to go to parameters, geometry, surface. We're going to plop that in, and then we're going to right click it and then go to set one surface as we do. So now this is referenced. So essentially what we're going to do now is we're going to want to make a list of points on this surface. And when you image sample, so you'll see here image sampling Grasshopper, these image samplings, they have resolution. So in this case, each of these little polygons are 1 pixel. So you need to essentially choose how resolved your image is. So you can see here, maybe this image has lower resolution than this one here. So the way we do that is we go to surface right here, utilities, divide surface, and then we just take the surface component. So if we look at this here, generate a grid of UV points on the surface, so that's going to be this here. Our U, number of segments in the U direction there, number of segments in the V direction there. So what we're going to do is we're just going to plug surface there, and now you can see we have a bunch of points. Since this image is fairly square-ish, we'll just grab a slider. So that's in parameters, input, number slider. And we're going to plug that into both U and V. So you can see right now there's no points. Now there's 1 point, the bare minimum. So what we're going to do is we're going to double click this slider where it says V count. Yours might say U count. And we're going to change the slider accuracy first. Going from rounding, we're going to change it to integers. So that's the N there. The minimum we'll want is, let's say 8. If we have 8 cells in this image, 8 by 8, it's going to be so low resolution that we won't be able to see the image anyways. But if you want something a little bit more abstract, maybe that works. Max, let's go 40, like so. So now you can see we can really increase the resolution. So there we are. Now the next thing we want to do is we want to do the sampling itself. So in this case, the reason why we have this image here is we want to reference the dimensions of this image. So in this case, we're going to go to parameters, input, image sampler. So this is kind of where all the magic happens. And what we're going to do, I'm just going to hide this image right now so we can look at it. So we're going to plug our points into this image sampler. Like so. I'm actually going to flatten these points like so. And then, so the image sampler, you can see it has this little exclamation mark. If you double click on the image sampler, so again, parameters, input, image sampler, essentially you're going to get a bunch of these things. So X domain, Y domain, channel, all of these channels, file path. So we're just going to kind of play around with it to see what everything does first. So first of all, let's choose our file path. So you can click on the little dots here to open up a file. So navigate to your image, Fedora dog, and let's just click OK. And you can see nothing happens. That's okay. Essentially, we need to have something that visually represents this. So in this case, why don't we go with little circles? So I'll show you how this works. We're going to go to, let's say, what's it outputting here? So right now it's outputting the RGB colors. So I guess this is the first thing we should adjust. So do you guys know how RGB works, more or less? RGB colors? Is that a yes or no? Yeah, like, so RGB colors, just to quickly look it up, is something you can see these colors here. As we go around here, there's different values of RGB, so red, green, and blue. So on a screen, when you mix red, green, and blue, the max being 255 of each, or apparently in this 1882, but it is 255 of each, you're gonna get white. 255, come on. Like that. So you'll see, whereas if you mix 0 of all of them, you're gonna get black. And any of them in isolation is going to give you, like in this case, red, green, or blue. Like so. So essentially what Grasshopper is doing is it's looking at all of these little pixels here. So at each point here, it's analyzing this image and saying this pixel is this RGB color. Since this is a grayscale image, we don't need all this. So what I'm going to do is I'm going to double click this image again. And then I'm going to go to the last one here and go to color brightness. And essentially this can be a stand-in for sampling a black and white image. So color brightness, let's click that there. Okay. And now you can see it essentially gives us a number that ranges between 0 and 1. So 1 being white, 0 being black. So let's increase our V count, get a higher resolution. You can see we have a bigger range here. So essentially, what we do is, let's make a little test to sort of see this. So essentially what we're going to do is we are going to go to curve, primitive, circle, we're looking at our circle size. Sure, that looks, fine. It's not too big. And then what we are going to do is for the radius, since we have these values here, we're going to plug the radius into the image sampler. And we're going to see what we get here. So it's not going to look right yet, but we'll get something weird looking. So does that look like a dog in a fedora to you guys? Not at all. So we obviously have to do some more adjustments. Maybe another fun thing we could do to show you how we can use color, and it might be a better way to visualize this. What I'm going to do is I'm actually going to take these circles, and let's go back to RGB mode. So I'm double clicking this, going to RGB. Essentially what I'm going to do is I'm going to make surfaces with all these circles. So surface, freeform, boundary surfaces. So what this does, boundary surfaces, it just takes any flat closed curve and makes a surface with it. So now it's going a little bit slower. Always save your Grasshopper. I'm actually not sure why it's going so slow. Well, actually, I know why. It's because we have like 800 circles. So a lot of times in Grasshopper, you can wait and it's going to unfreeze itself. If it doesn't, one thing you can always do is if it turns white, hit not responding. This is a little trick that sometimes works, sometimes doesn't. If you keep hitting escape, eventually, like I know it seems futile, but it actually will force it to crash. It's like you have to hit the exact right moment. And when I say it'll force it to crash, it'll give this little icon. I don't think it's going to work here, but sometimes you get lucky. When I was younger, I was always so bad at video games because I like cannot tap very quickly. So I'm just going to close that because it'll just take a second to reopen. So does anyone have any questions about the image sampling or? Okay, yeah. Okay, let's review everything. Okay, so quickly reviewing, to put in the image, you use the command picture frame. So you type in picture frame and then choose your, I don't know, the picture of the cutest dog you have on your desktop. So you just click that. You place its corner wherever you want. For this, it's actually good to place it 0, 0 and drag outwards like that. You also always want to make sure that it's dragged out orthogonally. So essentially, its two edges line up with the X and Y axis. So I'll just go like that. Okay, so again, we're going to open Grasshopper. And so again, to quickly review, we're going to select this. We're going to go to parameters, surface, to reference it. So set one surface, we can see its reference because it turns red or green when selected. We're going to go to surface, utilities, divide surface, like so. We're going to go to input, number slider, drop that down, plug into both U and V so we can have control over the resolution. We're going to double click the left hand side of the slider to edit its range and also change its floating point numbers to integers. So in this case, I'm going to go 8 to, I'll say 30 this time. So now we can see these points here. And now that we have these points, we can go to image sampler. So essentially what we're going to do is we're going to go to parameters, input image sampler, like so. And then we're just going to plug our points, which we're going to flatten first. So we'll flatten our points. And does anyone have an idea why we flatten our points there? Thinking back to matching branches with everything.
You don't want any of the points to be in hierarchy with each other, so that you can get assigned a circle.
Yeah, more or less. Essentially, there's only one file we're referencing, so we only want one list. So again, you want to match data for data, so we're just plugging that in. This exclamation mark, we get rid of it by double-clicking the component, changing the file path to the same image we're referencing. And then right now we're going to go to RGBA colors and we'll leave the domain for now. So there we go. So this is just going to give us a bunch of RGB colors. What I'm going to do this time actually is instead of crashing Grasshopper and trying to do a bunch of circles, I'm actually just going to create a bunch of spheres. So I'm going to go to surface, primitive, sphere. And you can see it asks for the base plane, so we can put our points there. You can see we have a bunch of circles. The radius we'll just leave for now. We can leave it at 1. And the resulting sphere, we have a bunch of spheres. Now what we're going to do to let us see if we're sampling this image correctly is we're going to go to display. So this is how you start working with color in Grasshopper. So display, preview, and then custom preview. And you're going to see here, so first of all, when you see a component like this that has edges like that, it means that it's just going to preview something or it's just going to output something. You can't, it has no output to plug into other components. So it's asking for the geometry to preview. That's the sphere here. So we're going to plug that in. So you can see by default it's this pink color. So the preview shader override, we can plug all these RGBs into here. So now you can see something's going on. Is it a beagle with a camera? No, although it looks like right there it's starting to, for some reason, line up. So obviously something's kind of weird here. Isn't that crazy? If you zoom really far out, your mind actually kind of puts it together. So let's increase this, but can anyone guess what's happening here? Why is this giving us such weird things?
Is it like trying to decide which is the most dominant color in like a really big area, and then
Yeah, that's actually it. So essentially what's happening here is, in the reason why it's doing that, so essentially what it's doing is, let's go and look at our settings here. Essentially you can see that there's this X domain and Y domain. Now you can see it says 0 to 1 and 0 to 1. These are actual Rhino coordinates. So it's saying that it's going to sample this image from 0 to 1. So it's sampling it from, it's thinking the image is about this big, so tiny in both directions. So at each sampling point, what it's doing, you can see it's tiling. It says tile. If we go to, let's say, clamp, then what's going to happen is you can see it's only sampling one image, one tiny, tiny little image. Does that make sense to you guys? So even though we place the image here, Grasshopper, since its X domain is 0 to 1, Y domain 0 to 1, it's stretching this image so you can see 0 to 1, 0 to 1, just in this tiny little corner here. So what we need to do is we need to figure out the size of this image that we placed in Rhino. To do this is pretty easy. We can take the points here, because all of these have values, right? So if we go through them, so I'm going to go to parameters, input panel, look at our points here. They all have coordinate points, or they all have coordinates, sorry. So what we're going to do is we're going to break up this group of coordinates. We're going to find the lowest X value, the highest X value, the lowest Y value, the highest Y value, and that's going to give us our domain for sampling the picture. So to break up coordinates, you go to vector, point, deconstruct. So you can see deconstruct a point into its component parts. Put that down. You can see its input is the input point. We have a bunch of division points here, so we'll plug that in there. So now you can see an X. We're getting all the X values. You can see there in rows because we have a bunch of numbers repeating. Our Y values, you can see that they're changing as well, and our Z values should all be the same because it's a flat image. So in our Z axis here, you can see all our points are 0 on the Z axis. So simply what we need to do, and it's strange that there isn't a plugin for this, that you have to manually type this in. But essentially, we just need to go to math, domain, and then bounds. So create a numeric domain which encompasses a list of numbers. Essentially what this does is it takes all our x values here, if we plug in there, and it gives us the bounds around these numbers. So it says these points range from 0 to 70. We're going to do the same things for y. So let's look at our bounds. So 0 to 70 as well. So now we know that our x domain is 0 to 70, our y domain is 0 to 70. So if we go back here, put 0 to 70, 0 to 70, hit OK. Look at that. We have a dog. So does anyone have any questions about that process there? Yeah, so if you have a weird number, essentially what you can do is you can go to parameters, input panel. So the panel is going to help you with a lot of things. Just grab two of those panels like that, and then you can right click a panel and then go copy data only, and then go into here and then just control V, and then that's going to paste it in. So you can see that even if we decrease the resolution here, the dog image still stays the same because it's sampling in that domain that we set. So usually, unless you're kind of doing a facade which is I guess multicolored, usually you're not going to do something like this. Perhaps instead you're going to have openings differ on account of the grayscale here. So what we're going to do in this case is we're going to get rid of these spheres, and instead we're going to go for some circular openings. So the first thing we want to do is go to curve, primitive, circle. We're going to put all our points into the points in circle, the points input, and we're going to double click on our dog image here. We're going to set our channel to color brightness because we know this goes from 0 to 1, so 1 for white, 0 for black, and we're going to put our radius in here. So now you can see we have this opening here. Now there's a few things we can do here. So let's say we have these openings, and the first thing we want to do is we say we want to inverse that. We want all the darker colors to be openings and all the white colors to be closing. Does anyone have any idea how you do that? Just again, it's not a Grasshopper component, it's just kind of like logic here. So we have all these numbers ranging from 0 to 1. How would you inverse those numbers?
Reversing? Forward it, like then account for the darkest one is the lightest one, and like if the darkest one becomes 0.
Yeah. So how do you make the darkest one 1 and the lightest one 0?
Where you can I forget what it would be from.
So yeah, you could use the sets or the math domain remap numbers. So that'll just remap your numbers. Or else an easier way to do this is just minus all of these from 1. Because if you think about it, 1 being the brightest, 1 minus 1 is 0, 1 minus 0, which is the darkest. Essentially, it's going to flip all the numbers. So if we just do that, go to subtraction. So now let's say we want A, so item to subtract from. Set data item 1. Let's commit changes. Or, sorry, don't want this. So the image sampler we're going to plug into B. So now if we plug this in, you see it's going to flip essentially. So this is going to be our wall right there. Now,
I'm seeing a lot of X's and
okay,
service flow.
yeah, if you're seeing things like this, so one thing I do when I'm working in Grasshopper is, like, obviously we can't see anything here. Usually just out of habit, I'll go back and I'll preview off everything preceding the step I'm working on, unless I need more than one thing. So in that case, that's probably what happened. Now, let's say, so we're just going to make like a wall. Like, let's say you want to CNC this. The first thing we need here is the outlines of this surface. So this will be easy. Essentially, we can go to Surface, Analysis, BRep Edges. This is just going to give us the edges of the surface. So that's Surface Analysis, BRep Edges. Plug that surface into this component. Now you can see we have that wall there. Now, the one thing though here is we have a lot of circles here which are tiny, tiny, tiny. And let's say we were CNCing this. Essentially, these circles might be smaller than our drill bit, or, you know, in this case, they're right on the edge, or we just might not want those tiny pin lights. We might actually want just this image here. Does anyone, can you think of any way that we can kind of say, like, if you were going to tell me to get rid of all the circles but the ones that kind of make up the dog, what condition would you say? How would it tell me to get rid of all the what circles?
Like the less than circle.
Exactly, yeah. So you'd say, like, get rid of all circles that are smaller than a certain size. So this is what conditionals are. So in the same way that, you know, you guys plugged your answers into that bird component I made, it tested if the answer was more or less right, unless it messed up. It was a conditional saying, is this answer right, in so many steps. So we're going to get into that now. So essentially, to get rid of these circles, we just want to see if their radius is a certain size. So the way we're going to test that is we're going to go to Math, Operators, and then we're going to go to Larger Than. So essentially, larger than, it does exactly what you think. It's going to give you a true or a false as to whether or not some value is larger than another value. Since all our values here are 0 to 1, we're just going to go to Parameters, Input, Number Slider, and we're going to say number to test against. We're going to put the number slider into there. And then the values we're going to use are our inverted values we got from our image sampler. So in this case, the result of the subtraction, the radii of all these circles, we're going to plug into A. So now you can see what we have here. So I went to params input panel just to see what's going on. You can see if we go to the greater than here, we're just going to get a bunch of falses. You can see if we increase this, they're going to turn to true or a mixture of those. So now that we have a bunch of trues and falses, essentially what we're able to do is we're able to get rid of certain circles if they don't meet this condition. So the way we're going to do this is we're going to use a component called call pattern. So we're going to go to Sets, Sequence, Call Pattern. In this kind of getting rid of things because they don't meet a certain condition is really, I'd say, like the single most powerful thing Grasshopper has over Rhino. So we're going to go to set, sequence, call pattern. You can see it's pretty simple. It just asks for two things. So the list to call, that's going to be our circles. And our pattern, you can see that right now it's giving us diagonals because what's happening, let's preview off these circles, what's happening is it's calling, you can see false, false, true, true. So essentially that's saying out of those circles, get rid of one, get rid of two, keep one, keep two, get rid of one, get rid of two, keep one, keep two. If we plug in this pattern instead, what we can see here is that as we move this slider up, here, let's look in this, you can see that less circles are meeting the condition. So it's getting rid of the circles that aren't bigger than a certain thing until no circles meet the condition and there's nothing there. So this is a great way of, you know, like let's say you want to build this wall, you weren't sure if your fabricator could drill any smaller than a certain diameter, but now you can just adjust on the fly. So that's the way you can do that. Anyone have any questions about that process?
Could you just show, yeah, so we can
Yeah.
see what we're missing.
So essentially, yeah, so it's, you're gonna use the larger than to call. Once you had all these things, of course at this point, you could join these naked edges and you could make a surface if you so wanted, or you could probably just keep the lines. We're going to do a few other things with this surface mapping, the image sampling, because, so what we have here is, oh, let's get rid of, here, let's grab this one. You can see you can do some kind of interesting things. So in this case, you have your pattern. Of course, let's say you don't want it on a flat wall, but instead you want it to be on a curved wall. So let's say you want to do some really interesting like Zaha Hadid type windows. Do you guys like Zaha Hadid's architecture? Raise it. No opinion? 6 out of 10. Yeah, I think that's about right. Yeah, but if you want to do some interesting gradiated windows like this, which, you know, I actually think can be pretty cool, then you can do this. Another thing to think about this, so we'll get into one kind of practical example, but one thing, I'll actually just show you this because I actually have my, you can see my desktop's really messy from preparing for my like midterm thesis presentation. So mostly I'm doing an animation, but so this stuff, essentially I'm using a little bit more advanced version of it. So this is a diagram, but you can see here what I'm doing is I'm taking principal stresses within a wall. So in this case, the blue is lowest compression to red being highest compression, white being areas of tension. And I'm actually mapping that out into openings. So I'm dealing with what's called functionally graded materials. So essentially the materials change density based on the amount of stress that happens within the wall member itself. So in this case, if you wanted to do kind of a, not fake, it would actually be kind of accurate representation of stress in a building, you could do it with image mapping. Another thing here too is like this little guy I have here, which is really quite a complex pattern that I made before. You could do something similar like this, making a complex pattern and calling out shapes based on image sampling. This stuff here too is essentially, you can see it moves along a curve. It's just more complex sampling. It samples something else. But going back to the windows here, one thing's you could perhaps do like in that Zaha Hadid building, which had the windows that get wider and smaller, is do a solar analysis. And now this is something which you could even fake by painting on, which is fine. And I'll sort of show you how you could do that. So this technique, even though first we're starting off with a dog, it can have some real practical applications, but also some more, I guess, figurative applications as well. So the way we map it onto this surface, so let's rotate our dog back like this. So it'll just take a second because I have a bunch of things hooked up. Okay, here we go. So the way that we can do this is right now what we don't have these, we have our called pattern here. So I'm going to hide that again. So essentially to remap this, what we want to do is we want to just use one component to do the mapping. So it's called map surface. So you go to transform, you go to morph, and then map to surface. And this is the same thing in Rhino. In Rhino, when you go to transform flow along surface, this is the exact same command. So we want to go to transform, morph, map to surface. And you can see here it says map a curve onto a surface via control points. Its inputs are curves. So in this case, I'm going to put in these curves here. Now the surface here is going to be our, you can see it says base surface for initial coordinate space. Since our coordinate space is based off of this surface here that we are referencing, so the smaller one, we can select this and plug into here. So we know that that surface is this one here. If we want to double check, we can preview it on. We know that's the right surface, so we're going to plug that into our reference base surface like that. So I'm just going to preview that off. I'm going to hide this. And our target surface, so I just made this surface here. We can make another one. So just for this demonstration, you can make, a crazy surface. Let's go like this. And I'm just going to loft between these two surfaces. Maybe I'll raise this one up a little bit more. So I'm going to go to surface loft in Rhino. Click these two things. We'll go to normal. That looks fine. So there's our weird surface. Doesn't really matter. And we want to reference that surface. Set one surface. And I am going to increase the threshold for the circles just so it adds less to map. And then, so our surface for target coordinate space, we can plug in this new surface. So I'll actually hide this. So you can see there is our dog. Now, you can see that our dog's sideways. More or less, you can flip this, but the easy way to flip this, honestly, is just to unhide that original surface and then just rotate it. And then this way you have a little bit more control over your pattern as well. So there's our dog, it's upside down. So let's flip it 180. So there is our dog right there. So one thing to mention, of course, being Grasshopper, and it saves all the steps. If you were to go like this, you can see that the circles still go up and down on your surface. So that's kind of nice. It's not like you're stuck with one amount. So you can increase the amount there. Now, if you want to, let's delete this. Now what you can do if you want to, let's say, cut these holes out of the surface because we want them to be openings, is we can go to, I'll open this up a little bit, intersect at the top here. We'll go to physical and then surface split. And then from here, what we're going to do is you can see it asks for two things. So base surface, it's going to be this reference surface we have there. And then it's going to say splitting curves. We have all these curves here. We're just going to plug in there. It'll take a second to split. All the intersection commands are kind of more computationally heavy. So they're always going to be the ones that take a little bit longer to figure out. It will go. All right. So now you can see we have a bunch of these. Now, can anyone think about the one thing that distinguished is the surface we want, the outer surface, from all the smaller ones? It's the biggest. So if we know in something like this, if this is going to have the most surface area, the way we can sort of grab this big one out and make sure it's always the right one is to go to Surface, Analysis, Area. So again, area is a super useful component. We're going to plug in all these surfaces. So we have 346 of them right now. Plug them in. It's going to give us all the areas. So again, 346 of them. It might take a second, especially since they're all curved and everything. So you can see that it's giving us all the points for all these surfaces here. We can just preview this off because we don't need those points. And then what we're going to do is we're going to sort these surfaces by their area here. So to do that, we can go to Set, List, Sort List. Now sort list, it just sort a list of numeric keys. List of sortable keys, K. Essentially, that's just our guide list. So to quickly review this, if we have two panels here, we have 3, 2, 1, and on this one we have pears, apples, and oranges. Essentially what's going to happen is if when we put in the 3, 2, 1, it's going to be sorted as 1, 2, 3. So it just sorts in numerical order. And then if we put something in A, so optional list of values to sort synchronously, if we put this in A, what's going to happen is it's going to sort these in the same manner that it sorted these original items here. So if you have the same amount of items in each list, all your lists match up, it's going to sort the things plugged into A or more, you can have more inputs, as it does in K. If you have more items in one list, it's not going to work. And you can see it turns red and it'll say key and value lists have different lengths, so the synchronous sorting is impossible. So what we're going to do then is we're going to sort the areas. Since we know the surfaces themselves right here are in the same order and there's the same amount, we're going to plug that into A. We know also, since the first item in this list, since it sorts it numerically, so if we go to Set, List, List item, by default it's the first item. Base list, if we plug A into Bay list. We know that the smallest surface is going to be the first one in the list. So to get the biggest surface, all we have to do is actually just reverse this list. So we can right click the output and go to reverse. So now you can see if we preview off all of these, we have our openings in our surface. So does that kind of make sense to you guys? So that's kind of a way you can do this. So we'll be sort of like reviewing all these steps in different forms again. So if there's anything you're not sure of, just watch the video or I can help you. So we have this now. So that looks great. There's our dog panel surfaces. So when I was saying solar analysis, essentially what you can do to kind of fake it is something like this. So let's make another surface. And later in this semester, or this course, we'll actually look at another way of more accurately doing solar analysis. Maybe there's going to be a class where there won't be enough time to go through all the plugins, so we can kind of have like a democratic vote for what technique you guys want to learn. So I'm just going to close this again. So essentially what I'm going to do here is I'm just going to model something, and I'll save it in Dropbox if you want. But again, I'm just going to model something which casts a shadow. So in this case, I'm going to model a building which looks like, actually, here's one. Let's go for whatever this is. So this is our building right here. Like so. Essentially what we can do with this is, let's say we want to, oh actually I know another kind of sampling we can do. Okay, so this is good. So let's say we want to have each of these faces open based on its angle with, let's say, the sun. So what we're going to do is we're going to set this B rep here. So set one B rep. Sorry, this actually will be much easier with this surface, and then you guys can follow along. So if you want to have a surface like this, essentially what I'm doing just right now is I'm just making a surface which casts some sort of shadow, so it can be anything. Okay, so that looks good. So I have this surface like this. Essentially what I'm going to do is I am going to look at the areas at which it's extremely exposed to light, and the areas at which it isn't. So we have this here. What we also want to do is we want to have a little icon for our sun. So in this case we can have our sphere. This will be our sun. This will be our surface, and we're going to reference both of these things. So what we are going to do is we're going to go to parameters brep to reference our sun. So I'm going to click this little sphere here, right click brep, set one brep. So there it is. I'm going to right click this and name it sun, just so we can keep track of it. And then our surface here, we are going to reference it by going parameters, geometry, surface. So right click, set one surface. And essentially what we're going to do is we're going to try to replicate, and you know what we can do? We can actually put a light in the center of this so we can kind of get a visual representation in Rhino. So what I'm going to do is in Rhino, I'm going to go to the lights here. I'm going to hold this open. So does everyone have this little cone light who's following along? That little icon there? Well, we can go the lights right here. Sorry, my Rhino window is messed up from this projector. And I'm just going to put a light at the bottom of this thing, like so. So now when we go to rendered, so view rendered, you can see that it's actually giving us an idea of what the shadows will look like. So I'm going to group these. So let's say view shaded. So let's say I move these around, view rendered. You can see that the shadow changes. So this is just a nice graphical representation of what we're going to do in Grasshopper. So we have our sun, we have our surface. So our surface here, essentially what we're going to do is we're going to break it up into points like we did before. So we're going to go to surface, utilities, divide surface. We're going to plug our surface into the UV. And then what we're going to do is we are going to, again, adjust the resolution. So we're going to go to parameters, parameters, input, number slider. We're going to plug the number slider into both U and V. And then we're going to double click on the V count, change the rounding here to integers, the minimum to 8, and the maximum to 40. So now we can see it does the same thing like this. Another thing you can always do is you can figure out the length and height of this surface and base your UV divisions on that. But for now, we're just going to manually go through and adjust the UV. We might adjust it after if we have time. The only reason why I'm saying you might do that is because we don't get a very nice division along one direction. Since this thing is so much longer in this direction, we might actually want to go to V, put an expression. So expression, let's say x times 1.5. So again, the expression editor, what that does is it just allows you to modify the input. So in this case, it still adjusts, but you know around the V dimension, so that's around the width there, bless you, everything adjusts in a more even way. So we have those points now. And now simply what we want to do to kind of fake this sun per se is to find the center of this sun right here. So we can go to surface, analysis, and then instead of going to area, we're going to go to volume because this is a three-dimensional shape. So volume does the same thing as area does. It finds the centroid of the mass, which most of the time just equates to the middle point of this sphere. So let's plug our sun brep into volume. And then if you can see we didn't have that sun hidden, we'd be able to see the center here. But what we are going to do is we're going to draw or align simply from this center point to all these points. So let's go to curve, primitive, line. So this one here, you can see create a line between 2 points. The first component we looked at, more or less. The start of the line is going to be the center of the sun. And the points which we're going to draw to are going to be all these points here. So does anyone have any idea why we do something like this if we were kind of looking at a solar analysis? Yeah, you could actually, and that's the thing, like you could always use this for like making a nice image, like absolutely. Like, and one thing with Grasshopper, you can just like bake these at any time. What we sorry? Bake them.
Okay, that's like, is that like Grasshopper makes 3D?
Kind of. So if you go into line, right click on click bake. So just a review for anything you can. So essentially what's going to happen is if we exit Grasshopper, so I'm just going to preview off all of those things. Now all of those lines are in our Rhino file, so they're actual objects. So that's how you get things back into Rhino. So let's go to view shaded so we can see all our curves here. So the reason why we're actually going to do that is if you look at where these lines are, you can see, here let's highlight them like this, the ones that get intersected, so in other words they're blocked by other parts of the objects, they're the lines which fall into shadow. So essentially, here let's look at this here. So let's go back to Grasshopper, line, preview. So what we want to do is we want to see if these lines intersect with the object more than once. Does that make sense? If they intersect more than once, then it's like gonna cast a shadow. So here, let's look at this another way. So what we can say is, like, let's say we want to, like, you know, make a puppet show, a hand puppet show. I'm going to draw this square here, like so. Surface, planar curves. And then I'm going to draw another larger square down here. So I'm just going to reference this before to sort of show you what we're doing here. So the surface I'm going to reference is this one, set one surface. And then what I'm going to do is I'm going to take this second surface here, which is, we can say, our shadow surface. So parameters, geometry, I'll just reference one surface again. Set one surface. So essentially what's going to happen is if we look at our lines and we go to intersect, so physical, and then we can say surface curve. So that's intersect, physical, surface curve. It's going to ask for two things. The base surface. So this will be this surface here that we're checking if it gets in the way of this sun's light. We're going to put it right there. The curve, the intersection curves are going to be all these lines here. I'm just going to flatten them. So now you can see that essentially what's going on is it's going to show where these lines hit this surface. So you can see here what it's going to give me is a intersection point. So it's going to say intersection points. If we look at this, it's going to give me all of those, or it's just going to give me an empty branch if it didn't intersect at all. And I'm wondering, it doesn't give me a true or a false, but that's okay. So essentially we know here that if it intersected, there's going to be one item in this list. So we can go to set list item, or sorry, set list length. Plug in like that, and now you can see essentially what happens is that when this curve intersects with this surface, so in the case of 40, right there, 40, it doesn't intersect. 40 is 0. There's 0 intersection points there. So we can use this as sort of a test to see if we cast a shadow there. So in this case, what we're going to do is we're going to go to math, operators, and then we're going to say larger than 0. So by default it's 0, so we can just put the length in there. We want to flatten this so it lines up with all these lines. And then what we can do is we can use this to call our lines right here. So we can go to set, sequence, call pattern, like we did last time. And so the list we want to call is our lines here. And the pattern we want to use is the pattern that tests if there's any intersections. So you can see here that what it's giving us is essentially all of these lines intersect. If we don't want these ones, what we can do instead of larger than 0, we can just say larger than, well, I guess what would we do? We'd say larger than 1. So if is there at least one item there? So if that's the case, or sorry, larger than equal to 1. So it's going to call all of those things. If we want to inverse this, one way you can invert your selection in Grasshopper is go to parameters, primitive Boolean. So parameters, primitive Boolean. Plug in there. Right click your Boolean and then just go to invert. And then it's going to allow us to do this. So essentially what this is giving us here, if you want to like have a project where you're saying this is the shade provided, you can say this is our light source here, so you can move it around. And what you're doing is you're saying that the light beams that don't hit the ground, this is the shadow they create. So you can see here on the bottom there is this space where no light gets in. So does that sort of make sense what we're doing here? Alright, so what we can do then with a surface like this, our original surface here, so I'm just going to get rid of this stuff, get rid of this surface, so back to our original surface. So let's reference this surface, set one surface. You can see this is where the sun hits it. Is we're going to test if these curves actually hit the surface right on, so that means they're in light, or they intersect before they hit the surface, and that means they're in shadow. So what you can do is you can go to, again, transform, or sorry, intersect, physical, and then you can go to surface curve. I guess you could also go collision. There's a bunch of ways you could do this, I suppose. Mathematical, you could also go surface line. Why don't we try this one? That might actually be easier. Yeah. Okay, so you can either go physical, surface curve, or mathematical, surface line. This one's just sometimes a little bit faster. So it's going to ask for base surface. That's our reference surface here. the line. It's right there. And now what it's going to say is points. So you can see what's happening here is that there's a bunch of intersection points. So some curves, if you look at it, they have 3 intersections, some have 2 intersections, and some have 1 intersection. If you're looking at this, the ones that have 1 intersection are going to be the ones that are directly in the light, so you know they're going to be full, like bright. The ones that have 2 intersections, they're going to be ones that just, you know, barely touch it, or I guess maybe ones that somehow hit it like this, but they're casting a shadow, and 3 intersections means it's really casting a shadow. So essentially what we can do here is we can find the list length of all the intersection points. So we can go to, again, set list length, plug the points into here. Now you can see this is giving us the list length, so the amount of intersection points. We can flatten these like so. We know that if there's more than 1 intersection point, that area is in shadow. So what we can do is we can, let's say we just want to totally get rid of those lines just to see. We can say math, operators, we can say smaller than. So let's plug in this length, smaller than equal to 1. And if we do this, and then use it to call these lines, so we can go to set sequence call pattern. So line segment, let's plug into the list. The pattern we can put into the less than or equal to. And you can see what we get here is the areas which are in darkness don't have any lines attached to them because they're culled. So what we can use this for now is we can essentially remap some circles onto here. So if we want to make a pattern like we had before, we can make a surface down here. Does anyone have any questions about this, what we're doing here, before we go on? No? Okay. So what we can do down here is we can make another flat surface. So this is sort of our pattern surface. So I'm just going to go surface planar curves like so. What I'm going to do is I'm going to make sure they have the same amount of points. So I'm going to go to parameters, surface to reference our surface here, set one surface, and then I'm just going to copy this surface divide here. But instead we're going to plug in this surface so we can see what happens is that these two surfaces are essentially linked now. And then what we're going to do here is we are going to base the radius of our windows based on the lights here. So we know here if we, let's say our brightness is 1, so that's based on how many intersections we have, so that's like direct light. We want a smaller window, whereas if it's darker, so 3, we want a larger window. So this is good. So essentially what we can do is we can use the list length, so the amount of intersections, to create our varied openings. So in this case, we can simply go to curve, primitive, circle. So we can flatten this list. Our points are these points here. Our radii are going to be these points here. Now, if we look at this, view, zoom selected, you can see that these openings are way too small. So right here we can see they're much too small. This is a point where we'd use remap. So what we could do here to adjust this is we could go to math, domain, remap numbers. So remap numbers into a new numeric domain. So this essentially just takes all the numbers, let's say between like 1 and 3, and switches them. It'll times them by 3 if you wanted to remap it to, let's say, 3 to 9. So in this case, our values to remap are these number of items in L, so our lengths. Our source domain, since we know it goes 1, 2, 3, we can say our source domain is 1, 2, 3. And our target domain, this we can kind of play around with. So I went to math domain, construct domain. I'm going to plug that into our target domain. And now what essentially, and we can take the remap numbers and plug them into our radii for our circles. And now what this allows us to do, if I grab 2 number sliders, so go to params, input number slider, I'm just going to plug 2 of the, well, I'll edit it first, so I'll double click slider. Our range, we're going to go from minimum, let's say 1 to maximum 100. So I'm just going to copy this and plug into the beginning and end of my domain. So essentially, now you can see what this allows us to do is have control over the smallest opening and the biggest opening. So in this case, if we look at this, you can see based on the light, we have these openings here. Maybe let's increase this count so we have a little bit higher resolution. You can see our biggest opening is too big, so we can bring it down a little bit like that. Maybe we want our smallest opening to be a little bit smaller to get a bigger change. Now, since we have that, all we need to do is remap it to this surface here. So we can take these circles. We can do the same thing that we did last time. So we can go to transform, morph, and then map to surface. So that asks for curves. So curves to map, resolving circles, plug that in there. Base surface for initial coordinate space is going to be this new surface we made. So plug that in there. The target surface is going to be this initial surface we made. Plug that in. So now essentially what you can see we're getting, this one is right, is essentially we're getting a pattern based on our sunlight. So it's making bigger holes in areas that get less sunlight. Now I want to see, yeah, that more or less looks right there. You gotta remember that the Rhino preview isn't going to match up with the Grasshopper preview because we're basing it on these rays here, whereas Rhino's preview might be a little bit different. But let's see what we have here. When you're doing this, you might just want to like double check. So in this case, we should get bigger openings here, smaller openings here, smaller openings here. So that makes sense. So you could base your windows on this. This could also be a way to sort of diagram radiation levels on any facade that you make. So we can, of course, change this curve or this surface. It can be anything.